Hey class, so this brings us to estimating probabilities. We're going to take these next three items up. With regards to estimating probabilities, yeah, you won't need to know everything that was covered in the section. I'll just go over some of the items, that will be required to do this exam here. First of all, you want to know that probabilities um, that humans are, in general, very bad at calculating probabilities. So, say there's 23 people in a classroom. What's the probability that two of them will share the same birthday? Well, it would be very difficult for anybody to calculate that probability, but it turns out to be 1 in 2, a counterintuitive result, and that's just supposed to illustrate the idea, that we wouldn't be very good at doing probability calculation in that case, and neither are we able to do it, in general. Also, we tend to see, miracles or some other paranormal phenomena behind things that we think can't be mere coincidences, right? So and we do this all the time in our thinking, right? It's sort of like, Jungian synchronicity, right? Something happens, what's the likelihood that could have happened, randomly or arbitrarily? Very low. It must have been, the action of some mysterious power. So the point that the text brings out is that, over a long enough timeline, the very improbable is certain to happen. So, the universe is 13 billion years old or something like that, right? Over that course of time, right? The most improbable thing of things, is bound to happen. So that's the point that you want to keep in mind as you do the exam. Now we're going to you're going to have to figure out some probabilities. This is sort of like estimating probabilities 101 using a deck of cards. But for those of you who don't know anything about cards, let me go ahead and bring up where's this picture at? Here we go. So a card has 52. A deck has 52 cards, and it has 4 suits, right? You have hearts, clubs, diamonds, and spades. Each of these suits has 13 cards from ace all the way to king. Ace all the way to king, so it's 52 cards total. Now, if I were to ask you, what's the probability that you're going to get a heart out of this deck, right? So just take, it's a deck of 52 cards. What's the probability you're going to get a heart? It's going to be a 1 in 13 out of 52, right? Which is 1 in 4. So 25%, right, chance, if you will. Now, suppose I ask, oh, well, what's the probability you're going to get a 2 of hearts? There's only 1 in the whole deck, right? So it's going to be, the answer to that is going to be 1 out of 52. Okay. Now, suppose that, I take a deck of cards and I tell you to, pull something out and pull it out. It's a 2 of hearts, right? And I don't put it back in, right? And I bring the same deck and I say, okay, now with this deck, that's missing the 2 of hearts, what's the probability that you're going to get a heart out of that? The probability that you'll get a heart out of it is 12 out of 51, because, one card is missing, right? And there's also one heart that's missing, right? So you bring this down to 12, right? So this is what's called a dependent event, as opposed to an independent event. And in an independent event, you have the probability of something occurring, and some prior occurrence, doesn't affect the probability in this case. So it's independent. So for instance, if you flip a coin, right, probability that you're going to get a heads is 50%, 1 out of 2. Probability you get a tails is 1 out of 2. Every time you flip it, it's 1 out of 2, right? So the events don't affect one another, right? And they're all independent events. But what happened here in this second scenario, where I actually took a card out and then put it back, what happened in the prior event, ends up influencing the probability in the second event. So it becomes a dependent event. One more thing, this is the gambler's fallacy. So I'll just stay on here and write it up. So gambler's fallacy is where you have it's an argument which says, oh, you're going to get some particular result because look, you've gotten this result the last few times. So for instance, take the coin, right? Say I flip the coin, and I get 5 heads in a row, right? That's highly improbable occurrence, but it's possible. And and then this gambler said, man, look at this guy, he's on a hot streak right now. He's going to get another heads. Look, he's gotten 5 heads previously, so he's going to get another heads. There's 6 go. Okay, well that's the gambler's fallacy because the probability of actually getting a heads in the next throw is 1 in 2, right? It remains 1 in 2, right? So it's not any more probable, to get a head than it is a tail on the next event. And if you jump to the conclusion that that it is more probable because of the prior occurrences, and you're committing the gambler's fallacy. Confirmation bias. As educated folks, we are all going to be aware of what this is all about. Let me make sure I'm sharing the screen here. Okay, so confirmation bias. It's when we preference information that supports our preconceived opinions and tend to sort of neglect or minimize, reject information that that is in conflict with our preconceived opinions. So we have vulnerability to confirmation bias. It's part of our psychology, so we always have to be vigilant about that and put on our critical thinking hats, and do the things that the text mentions, to counter this tendency, to make sure, you're thorough, in your examination of the detail and things like that, right? Okay, let's see. So you're going to have to know how to identify all the fallacies. So, the homework that we did, where you were given a passage and, and the passage is an argument, and you have to figure out if it's a fallacy, and if it is a fallacy, then say which type it is, and you're going to get 20 of those questions. So you want to make sure that you go back and review all the fallacies.